Good morning. Looks like we're live, got a microphone working, and the preview is sort of up. All right, yeah, it's moving around. It's still a couple of minutes until 7 a.m. Mountain Time, so I'm going to begin by setting out some Slack messages over here to the side. I think I'm going to start, if I can, get up early enough, start the stream a couple minutes early, so that way if anybody comes here and wants to ask any questions, then I would be happy to answer them before I get started with whatever we're going to be doing. So let's see, where's my topic? There he goes. Sending all the messages off about the stream. Topic streaming. No, check this out in this one. I think one of the things I'm going to want to do is maybe create a bot. I could just hit an API using maybe create a binary with Rust or something else that'll hit all of the Slack channels that I want to hit, and maybe hit all of Twitter, Facebook, LinkedIn, wherever I want to advertise this stream, other things that I'm doing. So I don't have to manually do that. That feels like something I can and should automate. And it is 7 o'clock now, so we're gonna get the official show started here. We're continuing to go through the Rust language book, and we're currently on chapter 3.2, data types, working through numeric operations. All right, so we'll just get started. Rust supports the usual basic mathematical operations: addition, subtraction, multiplication, and remainder. All right, so addition, subtraction, star for multiplication, division, and okay, so do we call this modulus or just remainder here? Or modulo? I know that there's subtle difference between the two, modulus and modulo, and I can't remember what they are right now. All right, each expression of these statements uses a mathematical operator. Appendix B contains a list of all operators. That's nice. Boolean type. True and false. The Boolean type in Rust is specified using bool. The main way to consume Boolean values is through conditionals, of course. The character type. So far we've only worked with numbers, but Rust supports letters too. Rust's char type is the language's most primitive alphabetic type. Single quotes as opposed to strings that use double quotes. That reminds me of Java that does that. Oh, that's a weird. That's not like a normal Z. Or they're doing a weird font there. Oh man, they allow emojis as characters. Rust char type represents a Unicode scalar value, which means it can represent a lot more than just ASCII. Accented letters, that's where this Z is. And I want to check to see. I'm going to make this a little bit bigger. I'm not sure it's fully readable. All right, that should be good. Okay, so accented letters, Chinese, Japanese, Korean, emoji, zero with spaces. They're all valid char types. Compound types can be a group of multiple values of other types into one type. Tuples and arrays. All right, so now we're starting to get into potential data structures for ourselves. A tuple is a general way of grouping together some number of other values. We create a tuple by writing a comma-separated list of values inside of parentheses. Each position of the tuple has a type, and the types of the different values in a tuple don't have to be the same. All right, so let tup the value tup binds to the entire tuple, since the tuple is considered a single compound element. To get the individual outs, we'll use pattern matching to destructure. Okay, so this is, we do like standard destructuring to get out. But can we, will it do auto? We're at chapter 3, main. I don't care. Yeah, I tried installing the Rust tools a couple different times here, and they just haven't worked. I don't know if it's just the Linux system that it's not happy about. Maybe when the new version of Ubuntu comes out, I'll install that. I start over with this, and we'll see. Or maybe I can just try Atom or one of the other editors. I'm not really overly tied to any specific editor. All right, so what I want to do is try let my collection equals just a tuple of things, like the number 1, a character A, and maybe the string hello world. So these are 3 different types. Feels like it's claiming. Oh, that's just telling me what changes I have. Okay, so I want to now get these out. So let, and it's going to be so I'll do like index, my character, which is like, I don't know, alphabet. And hello world, which is going to be my hello, equals my collection. And then let's print line, where we're going to say, well, I think what I can do is just open close brackets, colon delimited. Index, alphabet, hello. Let's save this and see what we get. And make this a little bit bigger. Okay, so we're at the wrong one. I want to be in Rust book. Chapter 3. And we're in types. Okay, it's cargo run. Interesting. So that does work just fine. It does auto sort of like predict what it is. And I wonder if it's a best practice though to do what this is saying and say, this is what I'm going to be putting in here. But that's pretty cool. Oh, right. Right here, it's like, nope, you don't need to do that. You could do whatever you want. Okay, so we've done the destructuring. We can also access a tuple element directly by using the period, followed by the index of the value we want to access. Oh, this is different. Okay, so if I don't do this, you're telling me I can do my collection dot, and yeah, it's going to start with 0. This one, of course, be 1, and this one would be 2. Did I not type that in correctly? I did not. Hello, world. That's what happens when it's early in the morning when you're doing these. Okay, so that's super interesting that that's how we index, essentially, well, that's how we index these tuples. I'll be interested in see if there's other list type data structures that we can end up using here, and if they also are accessed through dot. Where am I? Here you are. Data types. Okay. Okay, here we got with this. This program creates tuple X. Okay, so we're good here. Arrays. So that's if we don't want to destructure them at all, which is an interesting idea. I don't know how I feel about that. Another way to have a collection of multiple values is with an array. Unlike a tuple, every element of an array must have the same type. Arrays in Rust are different than arrays in some other languages because arrays in Rust have a fixed length. Once declared, they cannot grow or shrink in size. That's interesting. I wonder if tuples allow you to grow or shrink them. That would be interesting. But arrays here sounds like arrays in C. So it looks like we can initialize them with data. I'm betting we can also initialize them and just say, hey, we want a new array of this length. Arrays are useful when you want your data allocated on the stack rather than a heap, or when you want to ensure you always have a fixed number of elements. They aren't as flexible as the vector type, though. The vector type is a similar collection type provided by the standard library that is allowed to grow or shrink in size. I'm not... So, knowing vectors and like the gaming industry definition of vectors does make me question the use of the word vector here. I wonder if there's just another definition that I wasn't thinking of before. The vector type is a similar collection. If you're unsure whether or not to use an array or a vector, you should probably use a vector. An example of when you might want to use an array rather than a vector is in a program that needs to know the names of the months of the year. It's very unlikely that such a program will need to add or remove months, So you can use an array because you know it will always contain 12 items. The other thing here is this is hinting that arrays might be better for essentially a constant, like a constant array where we're setting them in the code. Whereas a vector, we might be just setting them using user input. Accessing array elements. An array is a chunk of memory allocated on the stack. We can access elements of an array using indexing. Okay, so this is with bracket indexing. That's interesting. In this example, the variable named first will get the value 1. All right, so that's like completely standard arrays from what I remember in C or other languages. Invalid array element access. Running this code, so we have A, which is 0, 1, 2, 3, 4. So 5 items in an array. We attempt to get the 10th index. Let element equals, so we get that, and we will get. So it looks like it compiles just fine. But the problem is that it will, when it attempts to run, thread main panicked at index out of bounds. The length is 5, but the index is 10. Ooh, this is interesting. I want to try that for a second. This backtrace. I hadn't really noticed it before. Okay, so I'm gonna comment you. All right, so continuing down here, we're gonna have let my array equals 0, 1, 2. And then we're just going to print line, and it's this will be fine. And we're gonna say my array of position 5. Okay, cargo run. So we get this panic, but note run with rust backtrace equals 1 for a backtrace. Well, it doesn't tell me that this is an environment variable, but it certainly looks like it is. So I'm going to try export rust backtrace equals 1. I don't even, yeah, I think I do. I may not need to do this. I might be able to just do cargo run. Nope. And cargo run. Ooh, this is a nice. All right, so panicked at index out of bounds. Here's our backtrace. Standard sys Unix backtrace tracing, unwind the backtrace. So GCC. Okay, so it's going fully back. So here's our print, the default hook. Rust panic with hook, begin the panic, begin panic format, begin unwind, panic format, panic bounds check. Okay, main line 21. Which is exactly where it is. So, I mean, I didn't get too much information myself necessarily, but we did get the line number out of it. I don't know if like there might be some times where the debugger doesn't give me that, and I can then use this to help out. Maybe that will. I don't know. let's go back to our book. Hey. Okay, so the compilation didn't produce any errors, but the program results in a runtime error and did not exit successfully. Yep, that's exactly what we found. Rust will panic, which is the term Rust uses when a program exits with an error, any error apparently. This is the first example of Rust's safety principles in action. In many low-level languages, this kind of check is not done, and when you provide an incorrect index, yeah, that can be done in C very easily. All right, so let's continue on how functions work. Functions are pervasive in Rust code. You've already seen one of the most important functions in a Rust language, the main function. We've also seen the function keyword, and we fail to attempt to use our own functions. Rust code uses snake case as the conventional style for function and variable names. In snake case, all letters are lowercase and underscore. Oh yeah, so that's what I did notice. And right now I'm not running the format because it wasn't installed when I installed Rust. But I'm guessing that eventually it's going to bring that in and auto change my code to this, or at least yell at me if I don't do it the way that it wants me to. Function definitions in Rust start with fn. They have parentheses after the function name, and then curly brackets as the function body. We can call any function we've defined by entering its name. So, yep, that's like how I expect it to work. It's the passing stuff back and forth. That's the thing I have trouble with right now. Let's start a new binary project named functions to explore functions further. All right, so we're going to do functions now. So cargo new -- bind functions. Okay, here we are. Place the another function example in here, and then it runs. Okay, so let's do that. Fn, another function, and we'll do a print line, and this is from another function. And then, so we'll call print line, and then we'll also call another function right here. Save it, and let's go cargo run this. So cd into functions, cargo run. And I think my head is blocking this slightly. There, that's we'll run it like that. That's easier to see. Okay, yeah, so that works exactly as we'd expect. But function parameters. Functions can also be defined to have parameters, which are special variables that are part of a function's signature. When a function has parameters, we can provide it with concrete values for those parameters. Technically, the concrete values are called arguments. But in casual conversation, we can do either. Yeah, that's like the same with almost all of the functions that I've worked with. Functions, okay. The following rewritten version of another function shows what parameters look like in Rust. So we have another function, we pass it the, this is the, of another function, x i32. When 5 is passed, in function signatures, you must declare the type of each parameter. This is a deliberate decision in Rust design, requiring type annotations and function definitions means the compiler almost never needs you to use them elsewhere in the code to figure out what you mean. Okay, so let's try this out, because they were using like a i32 for a assigned integer, and I wonder if I do another function in here and I do this 5 and I say, okay, I want like num, but it's a unsigned 32-bit integer, and we're just going to pass this in, put num in here. This should work because that it should be able to figure out what that num is, right? So we're gonna say cargo run again. All right, so that works. Let's try putting this 5 in here. So let my num equals 5. So we don't know exactly what it's going to turn it into there. We're going to put my num in here. Is the compiler going to look to see it's going to be used and auto determine what that should be? That would be interesting. It does. And so if I change this to an I, it also works. And what if I declare this? Now, if I put a .0, that will make this a float, I believe. Will this convert over? Mismatched types. Expected i32 found floating point variable. So I would change this to float. Oh, right. It's a different type. It's not just float. I would need to go back and remember what the data types here are. Integer types. F32 and F64. Right. Okay, so F32. And then it works. I don't know if I can like parse it or something like to convert it easily, but that's a problem for another time. But that's nice to know. Let's come back here. Okay, so we get that. The declaration of another function. All right, we got that. This is all exactly the same. This example creates a function with 2 parameters, both of which are i32 types. I wonder if I use a tuple for this. So let's say I have x and y coordinates. I mean, that's pretty common if I'm making a game or something. So if I say like x, maybe it's going to be like player position is going to be equal to like 35 and 42. And this is going to be their x and y. And so we want to call another position and pass player position in. Now in here, we want to destructure this right inside of here. And I wonder if it will do it automatically or if I have to do something like parentheses inside of here. And we'll do X, unsigned 32, Y, unsigned 32. And in here we want X and Y. All right, let's see if this works. No, it doesn't. Expected one of, okay, so it didn't like that. I wonder if I don't need the parentheses here. This function takes 2 parameters, but 1 parameter was supplied. Oh. Okay, so we can't do destructuring quite that simple inside of the parameter here. I think that what I can do is do this and do let x, y equals underscore. Expected colon. Okay. Is tuple a valid data type? I don't think it is. Let's go back to, oh, we had data types here. Back down to tuples. Okay. Let tuple, and then it's gonna be, oh, so I have to tell it specifically what the tuples are gonna be in. So I think unsigned 32, unsigned 32. Expecting expression found this. Well, okay, so it liked the other one. So maybe this is special. Position. Oh, and there it works. Okay, so unless like later on I found out there's some way to destructure inside of the function parameters, I am going to have to do something like this, or grab the position to say that, hey, this is going to be a tuple of these values, and then unpack them here with destructuring. Which is a little bit sad, but totally understandable. It doesn't add too much problems to it. Let's go back to functions. We did those. Function bodies are made up of a series of statements, optionally ending in an expression. So far, we've only covered functions without an ending expression. So let's look at what statements and expressions are and how their differences affect the bodies of functions. We've actually used statements and expressions. Statements are instructions that perform some action and do not return a value. Statements do not return values, therefore you cannot assign a let statement to another variable, like that. When you run this program, the error you'll get looks like this. Well, yeah. Variable declaration using let is a statement. Yes, you can't do that. The let y equals 6 statement does not return a value, so there isn't anything for x to bind to. Expressions evaluate to something and make up most of the rest of the code. Okay, which does make sense. So like expression might be 5 plus 6. The block that we use to create new scopes is an expression, for example. Okay, so we can do something like let y equals, create a block, and then do some code inside of there. It scopes all the variables to that, and then returns. Is a block that in this case evaluates to 4. That value gets bound to y as part of the let statement. So I think someone who line without a semicolon at the end, and there's no semicolon there. Unlike most of the lines you've seen so far, expressions do not include ending semicolons. If you add a semicolon to the end of an expression, you turn it into a statement, which will then not return a value. But can I use return with this? I want to try that. I mean, I know it's about to tell me, but I want to try it anyways and sort of understand this. All right, so if we do let's x equals, and then we have a block here. We'll do let y equals 5, and I want to I'll first do it the way they do it, which is y plus 1, no ending semicolon, end right here, and now we can do our print line x. So we save this. Let's go cargo run this. Yeah, it gives me this warning, but we get 6 out of here, which is exactly what we were expecting to get. But if I come in here and I add the return statement, return y plus 1, and then explicitly put a semicolon on here, okay, mismatch types. Expected parentheses found integral variable. All right, so it's trying to tell me put parentheses around these. No. Unnecessary parentheses around return value. Okay, so we cannot have return that's in a block that's not defined by a function. Now, can I do a return in this another function? So instead of this print line here, what if I took this let x and y and I returned x plus 1? Now I want to say, okay, I want to have let player position back again. We're going to call another position, but we're going to set let x equals another function. I'm going to save that. Hey, it didn't like that either. Okay. Parentheses doesn't implement standard format display. What is inside of X? Expected parentheses found unsigned 32. Ooh. Try adding a return type. Unsigned 32. All right. Like, I am right before the section that does this, but I do find it fun to like spend just a little bit of time to see if I can figure out how to do that. Like, do I put this here? This reminds me of, is it Java that puts it here or up here? I cannot remember anymore. Expected one of arrows where, oh, those arrows. Okay, yeah, there's something to do with arrows that I could do. But yeah, it definitely doesn't like these functions. I'm gonna undo this. There. This should get us back to compiling again. Yes. All right, let's come back here. Functions with return values. Functions can return values to the code that calls them. We don't name return values, but we do declare their type after an arrow. That's exactly what it was trying to tell me, was that I was missing, oh, I got rid of it. I was, if I wanted to do this, we'll do this, comment this out, and I'll say let x equals another function. We're going to pass in player position, and you are going to say you return an unsigned 32. Mismatch types. Okay. Expected U32 found. Oh, because I didn't actually return this. So I print this in the function. But then I also want to return x. And we get 35 out. That's exactly what we were hoping to get. So, okay, that's how we set what type the function is going to return, this single arrow. And main doesn't return anything, so it doesn't need that. Running this code provides an error. So where we have +1, consider removing this semicolon. Okay, can I do that here? Where I just put in like x. Heck, what if I just even do x plus 1? 36, and if I just do x, just like leave that here, that also works. Okay. I don't know if I like that, but it does. I mean, I can see that it's going to allow me to create really small functions, and if there's one-liners, that might make sense. All right, moving on to comments. Okay, so simple comments are the double slash. We can put them on lines of code like that. Rust has another kind of comment, documentation comments, which we'll describe in chapter 14. I wonder if those are going to be similar to like the Python triple quote comments that basically create the entire Python docs. But that was easy. Control flow. Deciding whether or not to run some code. Okay, so we're going into conditionals now. An if expression, okay. We already used this in our reverse choosing game. So like we do if, then the condition, and then blocks. An if expression starts with the keyword if, which is followed by a condition. In this case, it looks like it wants us to put the else up here, unlike what we did in ours. Let's try changing the number of the value of number to a value that makes the condition false. Yep, then that condition was false. Okay, there's no truthy or falsy. It must be a Boolean. Rust will not automatically try to convert non-Boolean types to a Boolean. Interesting. So 0 is doesn't work either. Okay, then we have our else ifs, which is kind of exactly what we expected it to be. Because if is an expression, we can use it on the right side of a let statement. Okay, this is different. Oh, because it's blocks, and then we don't use semicolons to then return this. Okay, that's interesting. Remember that blocks of code evaluate the last expression in them. Okay, and then these are the arms. Ooh, okay, hold on. Remember that blocks of code evaluate to the last expression in them, and numbers by themselves are also expressions. In this case, the value of the whole if expression depends upon which block of code executes. This means the values that have potential to be results from each arm of the if must be the same type. The results of both the if arm and the else arm were i32 integers. If the types are mismatched, as in the following example, we'll get an error. Right. And that's because it can't, oh man, it can't auto-determine. You can't even put it in there. I guess you could probably like build a tuple, maybe? I don't know. The expression in the if block evaluates to an integer and to a string. Okay, because it must know at compile time. It's not it can't wait. So it's a safety thing there for us. Repetition with loops. All right, we have loop, while, and for. So we've already used loop. It seems like it's a infinite loop, right? Yeah. It just loop this, do it over again, and then eventually you can break or continue. Then we have the while loop. So, I mean, it's pretty much exactly like the if statement that we saw. Just while this evaluates into true, do this over and over and over again. And then we have for. All right, let's see how fors work. Okay, so for element in a dot and call a special iteration method that must be on arrays. All right, let's try this. We're still in chapter 3, but we're in loops now. Let's get out and create another cargo new -- binary loops. Close the functions, open up the loops, source, main. Okay, so we want well, I want to try the for loop because all the other ones seem like they make sense here. And in this case, we're gonna do we'll do what they have first. We'll have an array. So let numbers equals an array of 0, 1, 2, 3. And then for num in numbers dot iter, I think it was. And then it's just a standard block. And then we can print line num. Cargo run. All right, does exactly what we expected to there. I kind of wonder, could we use this as some kind of like reduce and return from here into another thing? Like if I say let a equals, can I say it's not really I don't think it's easy to put in here. I bet we're not going to be able to do that. I could just have a value. Go down. Make you a. And we're just going to return 55. Unexpected token. Could not compile loops. Interesting. It did not yell at this specifically. I guess I needed a semicolon there. Okay, so it's not expecting to return anything at all. It's just a good old loop. The safety and conciseness of for loops make the most commonly used loop construct. Okay. You made it. This is a sizable chapter. Yeah. Looks like if you want to practice with the concepts listed in this chapter, try building programs to do the following. Convert temperatures between Fahrenheit and Celsius, generate the nth Fibonacci numbers, print the lyrics to the Christmas Carol, The 12 Days of Christmas, taking advantage of the repetition in the song. Ooh, okay, those seem like it might be nice to try. So I'm gonna copy that. It is 7:54, so we're not gonna be working on this today, but I think that we can start working on these tomorrow. So chapter 3, playing with code, and I want you. I don't know how to get multi-lines from this, so I'm not gonna care. Okay, so that will give us our full sort of goal for next time. We can start off by converting temperatures between Fahrenheit and Celsius. Yeah, it'll sort of like bring together everything we've done and play around with it. So with that, I am going to I'm gonna call it for the morning. I think we've gotten through a lot of cool stuff. I've got a lot of code that I want to push up before I forget. Everything's saved here. We're all good here. So chapter 3 finished for the most part. And push that up. I have a link to the code that's been pushed up in the description of this video. And I have, it is Friday, which means no streams tomorrow or Sunday. I am pretty much going to be doing these streams only on weekdays in the morning, and specifically when I don't have like some other appointments. Like yesterday I had an appointment that I had to go to, so I had cut the stream a little bit short. Anyways, I don't see any reason why I won't be able to stream on Monday morning, so I shall see you then. Have a great day and a great weekend.